Welcome to DevNation, and today we're going to be talking about push messaging and IoT and how it's going to affect things moving forward in all of our lives, even if we don't want it to. So first up, I'll let Luke introduce himself.
Right, yeah, so I'm Luke Holmquist. I'm a senior software engineer here at Red Hat. Do I have my mic on?
Yep.
Yes, I do. Okay, cool. So I am actually the JS tech lead for our AeroGear community project that deals with mobile. And if you guys want to stalk me, or follow me rather, there are some links to Twitter and IRC and blog. And if you want to be my Facebook friend too, that's cool. But I didn't put it up there.
And my name's Balunas. I'm one of the mobile platform architects and technical engineering manager for our mobile efforts at Red Hat here. I'm the founder of the AeroGear project, and I used to be the Rich Faces project lead for those who remember JSF. Long live JSF. And I'm also an open source advocate and been part of open source communities for years and years and years. So today we're going to talk about mobile push messaging, but we're also going to be talking we're going to go over kind of the classic use cases around mobile push, and then we're going to talk about how it's going to affect things with IoT and different things around that. So first of all, I wanted to ask, how many people in here have smartphones in their pockets? 100%. Excellent. How many people have ever received a native push message to their mobile phones? Should probably be 100% too. Excellent. How many people have actually developed mobile push messaging and mobile apps to actually send messages? All right, we got 3 or 4. All right, that's good. So what I wanted to do is kind of go over the workflow and kind of how mobile push messaging works for iOS specifically here, but it's also very similar with Google Cloud Messaging. So first of all, when you load up an application, it's going to register for push notifications basically at the iOS level. It's when it sends that little message up at the top that says, do you want to allow push messages? At that point, it's going to send a message to the APNS server, and it's actually going to send the device token that's part of that package to your application. At that point, your application is going to basically phone home to your server. Right? This is the part of native push messaging that you need to manage. Right? It's going to send that app, the token, and the information associated with that token to your server. On that server, you need to manage your SSL certificates and any other things that are required. For example, your P12 file for iOS, things like that. Now, when something happens on your server, right? Temperature, weather alerts, Amber alerts, whatever it might be. Your server is going to trigger a message over REST to APNS, to the APNS server. And at that point, the APNS server is going to look up its connection and actually send the message to the device itself with whatever payload you happen to want it to send. Now, what's important to note here is that this is how APNS does it. And like I said, it's similar with how Google Cloud Messaging or Windows does it, but it's different. Just enough to be a big pain in the ass, right? And so that's where something like the unified push server comes in. Now this is part of the AeroGear project, something that was developed and is available there as an open source project. Now what this does is it puts together all of the differences between GCM, Windows, even down to Firefox OS, things like that, and gives you a common interface for them. So as a developer, you create your app, you're working with one server to kind of manage all of those differences. And then when the app gets installed on the device, that phone home part is actually going to go back to the unified push server you've set up and configured. And there's security and keys and things like that go along with all of that. At that point, the push server is going to basically sit and wait. And when your business logic, and it doesn't have to be the JBoss application server, that sends that message is number 3 down here. The entire server is REST-based. So pretty much any server, any application that can send a REST message can trigger messages here. Obviously with, again, security, keys, things like that. So the message is going to get triggered for whatever reason to the server, and it's going to send out messages to whoever you just said. Now that could be Google Cloud Message, Android, so obviously Android, Windows, iOS, what have you. As a developer of the business logic, you don't need to care. You just say, send a message, and here's either a group of people, tags to use, things like that. And then the unified push server is going to take and deliver those as needed. And then it also collects some new things like analytics, how many people open the application because your push message, stuff like that. All right. And now we're going to have a quick demo around FeedHenry and mobile push, kind of using both FeedHenry and the unified push server.
Hey, Jay, didn't they just announce yesterday that it's now called the Red Hat Mobile Application Platform?
You know, in fact, they did just announce that yesterday, so thank you very much. If you saw the news announcement yesterday, FeedHenry is now called the Red Hat Mobile Application Platform, and so we're going to have a demo around that. Now, you might be asking yourself, where'd you go, FeedHenry? Right? It didn't just disappear. Right? We're actually going to be turning the FeedHenry name and code base into the open source projects that are associated with the technology. So if you visit feedhenryorg, what you're going to see is a landing page where we're starting to get all of that code base ready to go open source, and there's a lot of things that need to happen with that. So check here, check to the feedhenry.org, and what you're going to see is basically be able to sign up for a mailing list, check out the GitHub repositories that are available, follow us on Twitter, things like that. And we're going to continually update that as we open source more and more parts of the entire platform. So with that, I'm going to hand it over to Luke, who's going to go through one of the demos.
All right. The first thing here we'll show is actually, so this is actually what Jay was talking about, the feedhenry.org website. So there's places for following and connecting with us and with everything that Jay sort of explained. So this is going to be the landing page for basically the open source project of that. So let's go into this first demo here. So let's make sure we got the right one. All right, excellent. So right now we have, and you guys may have seen this yesterday during the middleware keynote. This is the mobile application platform, and here I've created a few apps, and a cloud service. But I'm actually going to go first to show what actually I did create, because we do have a push template that will create some sample apps for you, so you can sort of get started quickly. So you may have seen this list yesterday as well. Here we're going to scroll down, and there's this push hello world here. If we choose that, we see that there's a couple of client apps and a backend service. Let me give that a name. I'm just going to hit create here. We're not going to actually use this one. This is just sort of to demonstrate that this is the process you would go through to create that. Here we're just going to go back over to the one that we've already created here. And so under the apps here, there's two apps. There's the HTML5, which is a Cordova application. And then we also have this push console app, which will interfaces to the service to actually send a push message to the device. So let me just jump into this HTML5 Cordova app here. And your basic, I mean, you've seen this, probably maybe saw this yesterday, so I'm not going to go too much into it. But it's basically, your normal Cordova app. But in this case, the push plugin is already set up. We have this push config JSON file that has the information for our unified push server, along with the secrets. So if you want to tweet those, that's okay. I'll delete them afterwards. For the different devices we're going to target. And then also, like in the keynote, you can also build as well. So I've already built one for Android down here. And if I wanted to, I could actually, bring it back up, and in a second, it should bring up a screen that has a QR code. Things are running a little bit
Kind of
slowly.
struggling with conference Wi-Fi.
Yeah, right. So you can either download the APK file, and if you're comfortable with the command line using the Android developer tools, you can install it that way, or you could use your device and scan the QR code and install the app. So I actually happen to have the app installed already on this device. Let me just open up. We have a little camera here, so let me just open up quick the camera, which I should have probably done earlier. Okay. It's going to open up. And if anybody actually could get me a little cup of ice, we have a demo that I forgot to get the ice for. Andres, awesome. I don't want to say too much about it. I don't want to give it too much away, but it might be cool with the ice. All right, I'm going to stop with the jokes because that's just terrible now. Okay, let's see if I can get both of these things in the same. Oh, hold on, sorry, Jay.
You're all right.
Okay, I want to get both of these in line here. So, oops, that is not the right one. That's the next one. Okay, so what I'm going to do is I'm going to go to this push console app, and I'm going to open this up. Actually, there's a link, I believe. Everything is.
While he's loading that, you can see the preview up in the upper right corner,
Right, yeah.
change skins, things like that. It'll show you what the app is going to look like, that type of stuff.
Yeah. So this is just actually a normal web application, or basically a web page. And these categories were loaded through the service that was in sort of that middle column that we saw earlier. So let me just open up the app here. I can show you. I've already had it installed here, so. We have push, and we'll go to the subscriptions here, and we'll subscribe to a couple categories. We'll just say Red Hat, Summit, and we'll say, cool, JBoss. Right. So, yeah, so Jay, if you just push something there, and maybe just even hit select all, if you want.
So I'm just selecting what groups that I want to send a push message to here.
Yeah.
You ready?
Yep. Let's see if this works. So it'll say that, and here, look, we got a message that says whatever he wrote.
Hi all at DevNation.
Hi all at DevNation. So.
And that went all the way through that workflow, right? So through the FeedHenry back end, all the way through to the unified push server that's going to be integrated into that, and then out to the devices using Google Cloud Messaging here. And then you can also configure based on, pretend this is an ESPN app. You only want to send a message to all the people who like NFL or something like that. You can do that as well.
Yeah, so I would actually show you that, but last night we discovered there was a bug that it would, if you're trying to do a category, it would actually send it to all categories. So imagine, if you will, I sent it to one category.
And it would even work if the app isn't currently live.
Yep.
So if you send it again, right, it's not like a WebSocket connection. It's actually going through Google Cloud Messaging.
Here, let's see.
Right.
It's going to send up to the thing. Yep. And
Right. So you can see the message came through.
Cool. Oh, notification. Wow. Awesome. So I believe that is that demo. Let's see if I can get the displays back to not mirror, and we'll continue on. All right. What one? There we go. Alrighty. Okay.
And you can just fast forward through.
Right. Cool. There we go. All right, cool. So this,
Go ahead.
Cool, yeah. Right, so what do you guys just see there? It's basically, you saw an end-to-end, creating an app, configuring it for push, sending push messages. But we were using, GCM. Yeah, we were using GCM for Android to send it, which will also work for, you can actually do stuff that on Chrome, as well as Chrome package apps, it'll also work. If you're using Safari or iOS or something like that, it's Apple's push network and stuff. But these are all third-party services, so you're sort of locked into their sort of requirements and all that stuff. So it'd be nice, if there was some sort of open protocol that people could use, so they're not locked into these vendors. And well, sure enough, Mozilla decided to create this a few years ago when they released their Firefox OS operating system and their Firefox OS phones. So basically, this protocol was developed in the open the whole time. It basically uses WebSockets and HTTPS for its communications. And there's actually a few. So the original implementation of the server that Mozilla did was in Go. And they recently just changed it to, I think, Twisted Python. That's right. So we thought this was really cool. And so we decided to take that protocol and also develop our own simple push server. So we have a version in Vertex, but we also have a version in Nodejs as well.
And this is a great example of how, with open protocols, multiple implementations came up, and we started working together on that.
Right. Yeah. Yep. Yeah. And so we kind of worked with them a bit and got it going, which was really cool. Right. So if you want to do sort of the simple push thing by hand, I guess it could be fun.
It's simple.
It's simple, right? Because it's simple push. So basically, what you would do is you would just sort of, and this is JavaScript in case anybody got scared. So basically, you just create a new WebSocket connection. And here, for that WSS, the server here, that's Mozilla's server right now. That's their push server that's live, right, happening right now as we're talking, and it's just out there. So basically, you'd open up your WebSocket connection and register for all your different your events. So after you've opened up your connection, you actually have to send a particular message type of hello to the server to say, hey, I've acknowledged that we're connected, and the server will send some stuff back to you. And then you would actually then the next thing you would do is you would send a register message type, and this is like specifically in the spec what you need to do with a channel ID, so you can register with them. And then you'll get this pretty crazy HTTP link back. And that's what this whole thing is. And basically, so now if you want to get a push message, so I should back up and say that simple push is actually more of like a doorbell. It notifies you and it says, and there's no payload. It just says, hey, there's something on your server on this endpoint that you've registered. So you should probably go get it, do like a HTTP get or something. So, and you have to send a version with it. So as you increment the version, so if you send, in this particular example, it's sending version 2. If you were to send version 1 after you sent this, so this is you're doing a put request right here. So if you were to send a 1 after you did the 2, it wouldn't actually send the push notification to you because you have to increment the versions.
Beautiful.
So in both the Mozilla implementation and our implementation, it's if you don't send a version, we just do a timestamp. So, and that's sort of sort of a standard thing that they've been doing as well. So yeah. Right. So like I said, it's very simple because it's simple push, and all you need is really WebSockets here. So I think we can show a demo here.
I think it's time.
All right.
It might be time for a demo.
All right. So, pardon me with the screen thing again.
You can actually keep it mirrored once you mirror it.
Okay. Okay, cool. So hopefully this will work.
You want to go back to 16 by 1,000?
Yeah.
We need an app for this.
Yeah. Exactly. All right, cool. So let's close this up here. And go to my command line. So right here, I've already started. So this is our simple push server using the Nodejs version. Let me see if I can make this a bit bigger and nicer. Cool. So I hope you guys can see that. Whatever. So basically, yeah, so I'm just starting up our Nodejs version here of the server. And now it's running on port 777, my local host machine here. So, and then for the example here, we're going to actually use, we have a JavaScript cookbook for our JavaScript library, and we have a simple push example for that. And really all we got to do is, here I'm going to use Mongoose. You could use HTTP, or like a Python HTTP server, or whatever, just to serve the index page. But I kind of like my, it's just easy to type. Because I'm always spelling like Python wrong for some reason, I don't know. Yeah. So that's, okay, so we'll make this a bit bigger. There we go. Oh, yeah, that's not what I was totally looking for. All right, cool. So yeah. This page should look familiar because it was the previous example, which has nothing to do with what we're going to do right now. Because it was up. Okay, so if I refresh this page here, this is Webpush 8080. So let's increase the font here. So it's just a very simple thing here. It says, hey, look, our connection is established, and we'll go through the code in a second here. Basically, we're registering one endpoint, and this particular case, we're calling it mail. That's not going to really make sense to you right now, but when we look at the code, it will, hopefully. So, and when we register, it sends us back this crazy URL here. So what we need to do for this one is now we need to actually do like a curl and a put to this. So I have this program called Postman. It's I don't know if anybody has ever used it. It's a Chrome app if you're using Chrome, but it's a lot easier than doing curl. And you could actually set you can put in your different form values, but we're not going to put anything in. And then you can hit send. And actually, if you wanted to, you could get the curl from. There's a little button that you would click, and it would give you the curl if you wanted to actually do curl. So that should have sent us a message here. Of course, I think the Wi-Fi is giving us an issue, and it didn't. So let me just refresh this, and if it doesn't actually work, we'll just move on to the next one because the next one's a little bit better.
So one of the things that's important to note while we're kind of waiting for that is that what he's actually doing is connecting to a local simple push server. However, and you'll see a little later on, assuming the Wi-Fi holds up, we have another example where it's actually using the Mozilla simple push server for the exact same functionality. And because it's an open standard, you're not locked into a specific implementation, right? So if Mozilla is going to solve your problem, that's great. If you want to implement your own or build off of ours, you can do that as well.
Yeah. So well, it seems that the Wi-Fi is giving me an issue. So we'll just move on to the next thing here.
So what would have happened is basically it would have just gotten a message, and it, like I said,
yeah, and it would have had the timestamp and the version. Oh, wow, awesome. Just wait. Yeah, so we'll move on from this, and because that wasn't the very most exciting thing. All right, cool. So I believe the next demo we have set up. Let me go back to the slides quick here, if I can find them. There's actually a link. And a QR code that we're going to try people in the audience to go to here. All right, so let me just get to the correct spot because it doesn't like to save the thing.
There you go.
Cool. So what we're going to try to do is do simple push across sort of all you guys' devices and stuff. So you can either go to the tinyurl.com/agpush-demo or do the QR code. It doesn't matter. Depending on what works, really.
So go ahead and, if you want, load that up.
Right.
Has anyone got that loaded up? Now, one thing that's important to note is that the simple push protocol, as Luke mentioned earlier, is really focused around the Firefox OS devices. However, one of the things that we did on the AeroGear project is we created a polyfill. Right. For browsers and other implementations. So what that means is you can use simple push on any browser, and it'll start functioning correctly. And then you'll see a little later on some other implementations for it as well.
Right. Exactly. Yeah. Yeah. And I guess the only downside is that it's you basically have to have the web page open for it to do the notification. If you have the sort of the page closed, like X'd out, it's not like a native implementation where it's going to open it up. So, all right, so.
Why don't we switch over and.
Switch over here. Go back to Chrome. All right, cool. So I'm going to go to another project here that we had called Simple Push Demo. If that doesn't take all day.
Do you want to try hotspotting off the phone?
Maybe, yeah. Well, so that was just to show one thing, but let's this is the unified push server as it is now. Of course, actually, let me touch it. Okay, so this is the unified push server. This is a new, sort of a new look for it, thanks to the Patternfly team. So go check out their booth. It's over in the community center, room 210, I believe. And we have a member of the Patternfly team sitting over there. So, all right, yeah. So we should be able to basically send a notification to that app. And if everything works and you have it up, you should really just be able to see. You'll see an alert pop up on your device. And if we have Wi-Fi, then possibly it'll work, but we'll see.
Go ahead and give it a shot.
Yeah, it's still sort of going there.
Man, the network is horrible.
Yeah. We'll have to hotspot this one.
Sorry, guys. I apologize.
Everybody's still probably so wowed from yesterday's middleware keynote that they're just like in awe and can't even process this anyway. So.
All right.
Okay. Well, we'll move on and let me see if I can change this hotspot real quick, and I'll hotspot it from my phone because we'll see if that'll work for our other demos. All right, cool. Well, I can try that again.
Might need to reload that page.
Yeah, I'll probably do that.
Does anyone have it up and loaded, the tiny URL? I got it. You got it? Okay.
Let's see if my network is, okay, cool.
So much faster.
Oh, look at that. Thank you, Verizon. So I'm writing this test message in here, even though you're not going to be able to see it because there is no payload. The only payload is the version number for simple push. So we'll try that again.
Success.
So success, all right. So hopefully maybe you guys saw alerts on your thing.
Did you guys get it for the ones who had it up? You did get it? All right, excellent.
All right. So it's more than one, so we know. Yeah, all right, cool. And if you want, if you can see the person, maybe move over next to them, and then you can look at their device or something, whatever. Okay, cool. So yeah, so that's sort of simple push right there. Sorry for if it didn't work so well, but all right. So simple push is great, but it's actually it's a few years old, and it was sort of a standard that Mozilla was creating. So now the new kid that's sort of on the block now is called Webpush, and there's a lot of different. So you have Mozilla, Microsoft, and Google sort of backing this now. It's a real standard. And they're developing this in the open as well. And this is actually now all based on HTTP2, because HTTP2 brought with it some nice features, which I'm not actually just going to go into right now, but very cool. So then for us on the AirGear project, we actually, since we also created our own implementation of a simple push server, we took this protocol and we wrote another client in Nodejs for a web push server. And what's really cool about this is that Mozilla, who had written a Nodejs implementation of it, is actually using our Nodejs implementation to do tests with their Node server. Because we also wrote a server and a client for the web push, so now they're using it to test, and it's really cool to see the collaboration between those two things. And then we also have a Google Summer of Coder who is sort of who is doing sort of the updates as the updates come into the protocol, to the protocol. They're updating the server with those new bits. And then so what I just talked about was the server end of that thing. And being a JavaScript programmer and for the web, I usually focus on the front end part of it. So the push API is actually the thing that your browser would implement that you as developers would probably interact with if you're creating web apps. So currently Chrome version 42 has an implementation of this. It's slightly different, but they're actually and it's using GCM as the underlying push network. But they have stated, though, that eventually what they want to do is open it up so you can put in your own. So when you do register, you put in your own. If you wanted to, you put in your own Webpush server. So you could be using your own stuff. So it would be very open. It's okay. Hopefully your screen didn't break. So and then in Firefox, I think the nightly versions, it's definitely in progress. It's behind some flags right now. I recently saw that you can turn a flag on and you can actually change the server URL inside that. I have yet to play with it, but it is there. So,
All right. So now we're going to talk about where mobile and IoT start to intersect and kind of some differences and things like that between them. So I probably don't have to explain too deeply about Internet of Things, right? A lot of talks are on that. So things to obviously know about it's the concept is a global network of things. Not necessarily just machine to machine. It could be toaster to refrigerator. It could be person to person. Lots of different approaches there, right? So anything, almost any use case across multiple fields can really play around the Internet of Things, right? And you're also typically talking about devices with limited CPU, possibly limited network capability, different things like that. Sounds a lot like mobile, doesn't it? Probably about 5 years ago, right? Where the devices that we had were all relatively constrained. You had to worry about new things, new internet connectivity issues and others. And so it's important to recognize that IoT, while it is similar to mobile, and it has some of the similar constraints that we used to worry about with mobile devices, and now, frankly, our smartphones are as powerful as our laptops were, 8 years ago, yeah, exactly. Right? Which is pretty amazing. But with IoT, it is also different because you're not just necessarily dealing with a mobile interface and a user interface, right? So just because you have a smartphone doesn't mean that it's a smart device, and it doesn't necessarily mean that it's a connected thing, right? You have to worry about different things when you're talking about toasters, right? And in some ways, like Amazon Fire, their TV, it's based on Android, but they've changed a lot underneath. To make it fit on that little stick, but also they have a completely different messaging system for it. And whether they had to do it or not, Amazon has their own. For your Kindles and things like that, it's a completely different messaging format. Or another thing to consider, we're going to have smart homes, right? Some of us might already. You're going to want to have different considerations when you're talking about locking and unlocking your doors and looking at your cameras, right, that are around your house. You need to worry about security, data synchronization, and other things around that. Right? And so part of what's different in some ways is the messaging protocols. So there's MQTT is one example, and then constrained application protocols, the COAP. But then, as we kind of talked about earlier, some things like WebSockets and HTTP2 are starting to migrate into the realm of IoT, right? Because the devices are getting a little bit more powerful. And so what that means, they're starting to implement some of their HTTP stacks and things like that. Now, I'm not going to go through each one of these. I just wanted to kind of put up some things that are different or similar between these because these are pretty much very IoT specific protocols, or at least that's what they're primarily used for, right? One is many-to-many, one is one-to-one, one's TCP, one isn't, one has different levels of quality of service. But they're both open standards. They're both being developed and actively used. And what you want to use them for is really just going to be use case based, right? So I just wanted to throw that up as something to think about. And these are things that are going to be more and more a part of what we do with things like our mobile backend as a services and push messaging and other concepts are going to start to include some of these other protocols. Right, out of a necessity to keep connected. So now we're going to jump down and talk about push notifications for IoT. I think Luke's going to take over at this point.
Right. Yeah. So we saw push notifications on an Android device. Some of us saw simple push on a browser and stuff, but what about doing like APNS and GCM and all these things on actually so I have an Arduino board, but in any kind of really microcontroller, like a Raspberry Pi or something, what you can't do APNS on there, basically.
Right. While they're getting more powerful, they're not.
Yeah.
You wouldn't want to load in everything required for APNS or Google Cloud Messaging.
Right, yeah. So here's where you can use these open protocols and these open standards, like Simple Push or Webpush, to basically do messaging or push notifications on these little small devices. So like I said, these things are open standards, they're open protocols. They're basically just using WebSockets and HTTP2 to connect. Let's go. So this is actually, hopefully it'll be really cool. So we have this cool demo for Simple Push for IoT. I always think that says LOT. I don't know. But anyway. So let me skip out of here. But before I do this, so basically we're going to be running Node here, and we're going to be using the Johnny 5 JavaScript library here. So if anybody's seen Short Circuit, that's Johnny 5, yes. So basically, what this Johnny 5 thing does is it's written in Node basic. So it's written in Node.js, and it is sort of a layer on top of the machine code for the Arduino. So it translates all like the Arduino code basically. So it gives developers a higher level of abstraction to actually do cool stuff with it. There's some other boards, like there's a BeagleBone that actually will run Node itself.
Or Raspberry Pis or others.
Something, yeah, on the device. So, but this is a really cool and very, very popular JavaScript framework for working with robotics and stuff. If you've ever heard of like Node copters or whatever, that's the thing. Yeah. So let me jump out of here. And we will go to.
While he's switching, I love the fact that now with Raspberry Pis and Arduinos and stuff, all of a sudden we're back to the little EE engineering boards with the wires and stuff like that. It just makes it so much more physical.
Okay, so if we go to a terminal here, I can actually shut this. Oh, I'll keep that running, whatever. So this project, I actually want to go to my editor. So just 1 second. Here we go. Cool. This is the one. No, this is the next one. Right. Oh yes, cool shit is the name of the folder. So anybody want to make that bigger? Or?
Yeah, make it bigger.
Yeah. All right, cool. So this is just in regular Node.js require statements here. We're requiring Johnny 5 because we're going to be using that here. So we actually have a simple push client for Node, an implementation of the client side part of it in Node.js. We also have one in Java as well, in case that's what you're more familiar with. How many people are Java or JavaScript programmers?
Node developers?
Node developers? Or Java?
More mixed? All right.
Yeah. More Java people, I'm guessing. Right, this is, okay. So this little snippet here, I mean, this is really just initializing the board. And basically what we're saying is, and then we're setting up here. I have in like the different pins on the board,
right.
Which are kind of over here. I'm saying, okay, set this up. We're gonna use these 2 pins for certain lights because which you can't see now. I will go back to it. So basically, what we're gonna do is we're actually gonna register 2 different endpoints for Simple Push. One's gonna be yellow and one's gonna be blue. We have a yellow and we have a blue light here. And when we do our Simple Push. After we register, we're going to create some crazy URL, like I was showing you earlier. And then what we're going to do is we're going to do, when we do our put to that URL, what's going to happen is if it's the yellow endpoint, it's going to light up the yellow light, or just toggle the yellow light. And then if it's the blue one, it will toggle the blue light, because blue and yellow. So let's...
And I think it's important to note where you're sending this up above.
Yes, right. So right here you can see in my Simple Push URL where I'm going to send it to. I'm actually going to send it to Mozilla service. I could have just sent it to our local one that we had running before, but we can also send it to Mozilla's service as well.
So if you think about the path, right, that's being taken here, right, it's actually going to use Mozilla's public Simple Push server to send that message. So it doesn't necessarily have to be just within this board. This could be back at home. This could be right in a server room, wherever.
Right, exactly. So let's go back to the command line. That's where we run our stuff. Make that nice and big. All right, cool. So I believe this Node cool.
I'll ignore your folder names.
Yeah, it's not usual thing. So okay, so hopefully, I don't know if you can really see that because so basically, okay, so we're registering for the device, and it's saying that the things are already registered. Oh, sorry, I was playing with this before. Let me just clear out one thing quick. We got a simple push store here that we're saving stuff to. So usually what you would do is with simple push, and most push stuff is when you get the URL or the device token, you'd send it up to a separate server for saving. In this case, I didn't send it anywhere. So I need to delete the database that these things are being stored in. Oh no, I think I did the wrong one. No, I'm just kidding.
RMRF to the wrong folder.
Yeah, exactly. So so let's just run that again here, and we'll get the endpoints. I should mention this is a 0.0.1 implementation of the Node client, so that is the reason for that. Okay, so this beautiful output here, we're going to take, and here we have the blue endpoint here. So we're just going to take this HTTP.
And notice that's a return from Mozilla.
Right,
right?
exactly.
So that's,
right, yeah.
Mozilla said, here's your endpoint if you want to send that message.
Exactly. So what we're going to do is, let me just minimize this. And I want to get the board plus the this curl guy in the same thing. So let me just make that non-thing. Okay, make that very tiny. Make this a little bit bigger. So hopefully this will come out and you'll be able to see the light of the.
Got to make that a little bigger.
Yeah, because I can't actually see the. Where I got to put the.
It's a new. It's a new link. So.
That, and it's loading. Okay, hey, look at that. Awesome, I sent it to the blue endpoint. The blue light lights up. You have no idea how excited I was when I first All right, yeah. So, yeah. So if we send it again, it'll toggle it off and stuff. So let's get that yellow endpoint here, and we'll see if that works as well. Yeah, I was super excited.
You can see those are the two messages he sent in.
Right.
That are just being outputted through the.
Right, so we'll do that. And I'll put that in and say, send. Yay, yellow light. All right, cool. Let's send that again. Whew. Wow, it worked. All right, cool, nice. So now that was cool, I guess. You know? So the other part of that is what you can't really see. There's a little thing here is a temperature sensor right there. So what we're going to try to do here is I have it set up so when it gets below a certain temperature, and now this is where the ice comes in, if everybody was waiting for that. What I'm going to do is I'm going to try to get it down to below 32 degrees, and that's Fahrenheit. I know we're talking about open standards and all openness and everything, and the US is just not standardized, so I'm sorry. So what we're going to do is, what I'm going to try to do is get that down to 32 degrees, which is freezing. And then what's going to happen is that's going to hit 32. It's going to then use our Node.js sender for our unified push server, and it's going to send a push message to the Android device that and the Android app that we did in the very, very beginning and we installed. So before I do that, I actually need to get on the Wi-Fi for my hotspot, so this will actually work. So just have one moment while I type in my password.
And so while he's doing that, this is really tying in a new use case here, right? So not only can we send messages through the simple push protocols down to here, down to the device and have it turn a light on or off, we can also have this board act like a remote sensor that you could put in your house, your greenhouse, your server room, where have you. And then when it drops below certain temperatures or what have you, it can trigger to the unified push server and let you know what changed, what's different, right? And that could be it's too cold, too hot, whatever.
Okay, let's just do that. Boom. Okay, cool. So I don't know if I'll be able to put these. I'll just turn the volume on that. So that should be okay. So now, first things first is I need to we'll make this bigger.
Now keep in mind while he's starting that. This temperature sensor is about $1.50.
Yeah,
so,
exactly.
So it's not the most accurate temperature sensor in the world, but it does definitely do the job.
That's another notification right there. Email. Okay, so we'll close this one. And then node index is this one. So what we'll see when this connects is that, and don't mind those lights, they like to do that. So basically, we have a counter, and all the powers are basically it's divisible by 10. We're showing. So because usually it would just go, it would be really fast. So right, like we said before, it's possibly not 121 degrees in here Fahrenheit because that would be ridiculous. So the sensor is a bit off. So we'll try to get this down to 32. I found the best way is to get my fingers nice and cold, and then stick it on there. So, all right, let's check this out. Let's see. There, we're going down, at least.
Sort of.
Come on. It's not. Oh yeah, nice, cool.
Yeah.
So you can see that we're submitting things here, and if I show this, of course, the video isn't up when we switch to the video. As you can see, we've gotten all these messages here that say, "Oh my God, the server is frozen." So, yeah, yes. So that'll warm back up maybe, and eventually, and if we actually make that in the background, turn the volume on. Yeah, it's still below 32, so we'll go ahead and we'll just kill the.
Yeah, let's go ahead and kill
the
that.
process. Control C.
Yep.
All right. Yes, thank you very much. I'm off to run to get the server.
All right, let's
cool.
go back here. We've got about 10 minutes left, so we'll go through the rest here. So the last part we wanted to talk about was an outlook around mobile cloud services. And this is where I just wanted to talk a little bit about the Red Hat Mobile Application Platform and how that may tie into Internet of Things in the future, right? So for anyone that has checked out the Red Hat Mobile Application Platform, right, it contains very, very powerful tools for creating mobile applications. So the push notifications we already talked about, data sync, offline, storage, lifecycle management, keeps track of certificates, lots of things like that to basically make it easier for you to develop and deliver mobile applications along with the endpoints and then work with back-end services. It also has the integrated build farm that Luke showed. Now, I would say at this point, this is a fairly established workflow for mobile development, right? And I think that for IoT, it's going to emerge as a very similar way to develop IoT applications. And so you want the same services. You're going to want data sync and offline support. What if your sensor drops off the network, right? It needs to know how to give you the historical data, deal with things offline, right? Same thing with managing storage, both on the device and on the server side, or data encryption, right? The NSA doesn't want to give you, put a beacon on you and follow you around and then have you crack it and see their data, right? So they're going to want to encrypt those types of things. And so that's where the mobile backend as a service starts to provide more than just messaging, right? We focused on messaging today. But I think moving forward, we're going to have IoT devices act and be a lot like mobile phones and mobile devices that we use day to day. And so developing for mobile will very soon become developing for IoT as well, I believe. And this is just an example of where it kind of expands beyond just mobile devices. All right, so that pretty much wraps up our presentation and our demos. I wish we didn't have some of the Wi-Fi problems we did, but if you're interested in seeing any of the things that we did or have questions, feel free to ask us right now. And then here's some links to check out for the Red Hat mobile product, as well as the open source projects, FeedHenry and AeroGear, and some of our Twitter accounts you can follow. And then please remember to fill out your session surveys. I find it really important. I like to get feedback and kind of see how things went. So if you could fill those out, that'd be great.